Okay, so now we're going to switch to chemistry. For 17, we're going to fill in the locations, the charges, and the masses of the subatomic particles. So these three right here are my three subatomic particles. Protons are found inside the nucleus. It has a charge of protons are positive, and they do have a mass of 1 AMU. Our neutrons are also in the nucleus with the protons. The neutrons are neutral, so they have no charge, and they also have a mass of 1 AMU. Our electrons are found in the electron cloud, or the shells, or the orbitals, or the energy level, whatever it is that you are comfortable knowing it by. It has an electrical charge of negative, and it has a very small mass. It's 1 over 1,840, which is almost 0. So they just say, hey, we're going to say it's 0. So by looking at this, you can see that all of the mass of an atom is located inside the nucleus with our protons and our neutrons, which is why we do this part right here, which is number 18. How do you find the mass of an atom? Its mass number, its mass is located inside the nucleus, and the two things inside the nucleus are my protons plus my neutrons. Number 19, what two subatomic particles make up the nucleus? Well, we just said that as well. Those are going to be our protons and our neutrons make up our nucleus. So all of our mass is located inside of the nucleus. If we have protons and neutrons located here, and protons are positive and neutrons are neutral, then the overall charge of a nucleus would be positive, because the neutrons are nothing. They have no charge. Number 20, label the location of metals with a 1, metalloids with a 2, nonmetals with a 3 on the periodic table, and give at least 3 characteristics for each category. So my metals are all located over here. I always actually like to start with the metalloids. So I go like this, and we go just down like that. My metalloids are right here. We go top and bottom, top and bottom. Oh my gosh, it's top and bottom, top, bottom, just like that. And there are 7 metalloids. So our metalloids are here. There's only 7 of them. So this would be where my 2 would be, because it said to use 2 for metalloids. Anything to the right, to the left of that, all of these, including this 2, are my metals. So this is where my 1 would be. My metals here. And then we've got our nonmetals all the way over here. That would be where my 3 is. And with the small exception of this here, which is hydrogen, is also a nonmetal. So for metals, right here, some characteristics of metals are that they are good conductors of heat and electricity. They're also all solids except for 1, which is going to be mercury. Except mercury, Hg. That one is a liquid at room temperature, but if you put it in the refrigerator, it will turn into a solid. They're considered shiny, and that's one of the very easy things that you can easily see, and kind of the biggest characteristics you know about metals is that, hey, those are shiny. It's probably a metal. They're also malleable, which means they can be flattened into thin sheets and bent and shaped into any shape whatsoever. All right, my metalloids, I'm going to put those in blue. Really, the metalloids can either be solids, they can be liquids, or they can be gases. They are semiconductors. They have characteristics of both metals and nonmetals. Metals and nonmetal characteristics. And so they're good semiconductors. And then last is going to be the non-metals. So try to squeeze it in over here. So non-metals. Those are basically everything opposite of a metal. These are poor conductors. They are dull. They're not shiny. These can be solids, liquids, and gases. And they're brittle, so they're not malleable. Brittle means that they can easily be crushed into kind of like a cookie, into tiny pieces. Number 20, where would you find elements with similar properties located on the periodic table? So my big keyword right here are similar properties. So just like our families, we have similarities with our family members because we share the same DNA. And elements share similar properties with the people in their families, and families is just another name for groups. So groups share similar characteristics, mostly because of their valence electrons. The fact that they have similar valence electrons makes them very similar, makes them have similar properties, such as reactivity. Okay, number 21. What two pieces of information does the atomic number tell you? When we started chemistry, one of the first things that we taught you guys was 8, which was that atomic number equals the number of protons, and it also equals the number of electrons. And so we refer to that as 8, A, P, E. So the atomic number tells us the number of protons and the number of electrons. Okay, number 22. What are valence electrons and what do they tell you about an atom? Valence electrons, which I abbreviate VE, are found on the outermost energy level. They're the one furthest away from the nucleus. So, actually, not just outer energy level. So if you've got something like this, these here, let's say 1, 2, 3, this one would have 3 valence electrons. So we're looking at this one, and this one. We don't worry about these because these are already full. They have to be full in order to put any on the outside. So they help us tell us how reactive an element is. So if you have any question about reactivity or how reactive an element is, it will have to do with the number of valence electrons. The quicker they can get to 8 by either gaining or losing, the more reactive they are. I'm going to put that in there. The quicker to get to 8, because 8 is great, by gaining or losing electrons, the more reactive they are. So that means that the more reactive they are. So that means group 1 and group 17, because this one just has to get rid of 1, this one needs to gain 1. Because this one already has 7 valence electrons, so it just needs 1 more. These are the most reactive, Sorry, I'm using up all of this, but this is super important. Group 2 and group 16, because group 16 has 6 valence electrons. These need to gain 2, this one needs to lose 2, are the next most reactive. And really the only other one that I think you might get asked for is going to be group 18. Group 18, these are the cool guys. These are non-reactive because they are already full. They have 8 valence electrons, and 8 is great. They're full. They will not react. Okay, number 23. What is the mass number for a calcium atom if it has 20 electrons? Well, we know that protons plus neutrons equals mass. So if I look on the periodic table, I can see that my atomic number for calcium is 20. So I also know if this is my atomic number, that it also equals my protons and my electrons. So I'm going to put in 20 over here under protons because this is 20 protons. It tells me that I also have 20 neutrons right here. So 20 plus 20, my mass is now going to be 40, and the unit of measurement for a mass for an atom is AMU. Number 24. What elements would have similar properties to sulfur? Well, if I look on the periodic table, if I see similar properties, then I know that I'm going to need to be in the same group. So if I look for sulfur, sulfur is group number 16. And so any of those elements in group 16 are going to have similar properties. So I'm just going to list them on all. The first one right above it is going to be oxygen. And then there's sulfur. Then selenium, Se, Te, and Po. Those are all of the ones in group 16. Number 25, which subatomic particle gives an element its identity on the periodic table? Identity, there is only one. And if you do not know this, you need to make sure you know this. Protons determine identity. If I change the protons, it changes the element altogether. Okay, so for figure 1, I can see that I've got 12 protons. That tells me that I'm in magnesium. So 12 protons, according to 8, all of these 3 numbers are going to be the same. It also tells me right here in the nucleus that I've got 12 neutrons. My mass number is going to be, find out our mass by protons plus neutrons. So 12 plus 12 is going to be 24 AMU. My group, I can tell by looking at this. 1, 2, I've got 2 valence electrons, so that's going to be group 2. So group 2 valence electrons. That is reactive. It is just has to get rid of its 2. It needs to minus its 2 to have its second energy level full. And by looking at here, I've got 1, 2, 3 rings. So this is going to be period 3. And then the next one, figure 2, is going to tells me that I'm nitrogen, which is going to be number 7 on the periodic table. That means I've got 7 protons, also 7 neutrons, which I can see in here. And that also means that I also have 7 electrons because of 8. My mass is protons plus neutrons, so 7 plus 7 is 14 AMU. My group, I've got 1, 2, 3, 4, 5 valence electrons, so that means that I'm going to be in group 15 or 5A. I've got 5 valence electrons, we just counted that. And this has to gain 3, so this has pretty low reactivity, low to medium reactivity. And it has 2 rings, 1, 2, so now I'm in period 2. Again, guys, the quicker they can get to 8 by either gaining electrons or losing electrons, the more reactive they are. This one, just by looking at it, can easily get rid of its 2. It's not hard to get rid of 2, so it's pretty reactive for this one, for magnesium. Over here, they either have to get rid of its 5 or gain 3, which is going to be a little bit harder. So low to medium reactivity.